Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field.
Hey, have you ever been faced with the challenge of sourcing, installing, and programming a used control module in a vehicle? I know a lot of us have. It seems to be happening more and more often today with the volume of control modules on vehicles, the cost of some new ones, or even the availability of new control modules. In some cases, used may be the only option. So what do you do here? I strongly recommend checking out SJ Auto Solutions and Tommy Oliva. Tommy offers a cloning service for used control modules to make these things plug and play for the vehicle that you're working on. In a lot of cases, he is also able to source the control modules if you're unable to locate one for the vehicle that you're working on. But once you get connected with Tommy, he's going to offer fantastic support from start to finish to make sure that that control module is going to work in your application. He's also got tech support that he offers through his website, along with some free resources there as well on information about used control module programming. So make sure to check out SJ Auto Solutions. I can't recommend that enough.
Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for this week's episode. Thank you so much for joining me. You are stuck with me this week. I'm going to be talking about computer strategy and obviously specifically relating to the automotive world and the computers and control modules that we deal with every single day if we're doing any type of work on vehicles, especially diagnostic work. But that's probably why you're here. So the reason I wanted to point this out this week, like I said, we deal with this all the time, just about every day that we're doing diagnostics, and heck, sometimes even when we're just programming, we end up dealing with this sort of thing. But what I'm referring to is the strategy that is built into the control modules, most often to monitor or assess the circuits that it is connected to, receiving inputs from, or outputting voltage to. And there's a strategy that's programmed into these control units to assess those circuits, or just to, take in data and evaluate them. But it's going to have a way to determine whether that circuit is doing what it's supposed to or not, or if there's a fault in the circuit. And that's really where we see this come up in our world is, of course, if everything's working correctly, we're usually not dealing with it too often. We might use the circuit to, take in data. There's examples where on older stuff where maybe you don't have data PIDs on a certain module. I'm thinking of like older Toyota 4x4 module, for instance. You don't have any scan tool functions. So then you have to assess those circuits and see what's going on those circuits with some sort of measuring device, a meter or a scope or something like that. And so in that case, maybe we're assessing a circuit that's working properly. But most of the time, what we're dealing with when we're doing diagnostics on a car is the computer has assessed, so there's something wrong with this circuit, or something, or that what it's connected to, it's outside of the parameters that I've been programmed with. And so I'm either not going to do the function that I'm supposed to do, or I'm going to set a fault code and there's going to be a warning light on. Obviously, there's a ton of different scenarios here, and that's part of the problem. Part of why I'm talking about this here is that, especially in the independent world, but I'm sure it's true in the dealership world as well, there's a lot of different makes and models even within one brand. But in the independent world, we're dealing with, 20 plus years of vehicles of all makes and models. And guess what? Not all of those computers were built the same way with the same strategy. I mean, we could even point to one specific type of computer, like engine control module, and go to one specific circuit, like a throttle position sensor. And the strategy to evaluate and assess that circuit within a single engine control module might be different, and I can say it is different from one brand to another brand, to from 1 year to another year, from one engine to another engine, right? It's not all uniform. Now, the more you do this, you can recognize some general patterns. And there is a lot that is the same, right? We can take knowledge from one application and bring it to the other, but you do have to be careful there. I've been burned lots of times because I was pretty confident that I knew this is how this circuit works. And maybe you could say that with pretty good confidence, but this is how the computer assesses this circuit, and this is what the computer is going to fault for, or the computer will recognize this as a problem and fault for that. That's where you can definitely get into the weeds, because that's not necessarily true across the board. And I'm sure many of us have run into this and seen this, but it's the challenge that we run up against when we're trying to perform diagnostics, right? Our goal as a company, when we're going out to shops and doing diagnostics, is performing pinpoint tests to tell them exactly what the problem is and what they need to replace or do to fix the car. And that requires us to have a good understanding of not only the circuit, but also the computer that it's connected to and how it is assessing that circuit, in order for us to say that, yep, that is going to satisfy the computer if you replace this component or you fix this wire, whatever it might be. But that gets tough sometimes. We struggle with it, right? You're dealing with something new, and maybe things aren't quite making sense. You don't quite understand exactly how the computer is assessing the circuit. It's going to take some time. Now, you can use service info, and that can be very, very helpful. You can use databases like Identifix or diag.net or IATN, or even, Facebook and YouTube have some good stuff. Oh, maybe a podcast. And you could get some really good info from that. Identifix, and admittedly, I would say Identifix back in the day, with newer cars, they seem to have fallen off. But back in the day, they had really good testing strategies and explanations for the circuit beyond what the OE service information provided. And so you could go through that, and, obviously Identifix was used as a crutch of like, hey, what's the top hit? I'm going to put that part in the car. But you could use those testing methods, and it was a really good explanation of how the circuit worked, what to test for, what to expect. This voltage means this voltage means that. That's great stuff. If you can access that information, fantastic. Unfortunately, like I mentioned earlier, there are so many different applications out there, and there's a lot of one-offs too, right? Things that maybe no one else has dealt with the specific problem you have, or at least they didn't. It's not documented anywhere that you have access to. And on the service, like the OE service information side, there's info there, and sometimes it's very, very helpful. So I'm in no way saying don't read or just skip over the service info. Like if it's setting a code, using that code setting criteria, sometimes that can be incredibly useful and everything you need in order to diagnose something properly. But I can also say with great confidence that that is not always the case. And sometimes the information that is in there is extremely lacking, or just at such a basic level that it doesn't have the information that I want in order to test that circuit thoroughly, right? And the one that comes to mind that most of us are aware of is you get into some type of circuit code and they're just having you ohm check wires, and then if the wires ohm check correctly, replace X component. If that doesn't work, replace the other component, and then replace the engine harness. But I want more than that, right? I want to know, okay, is 7.4 volts supposed to be on that circuit? Is that normal? Does that satisfy the computer? When it goes to 8 volts, what happens? Is the computer upset then? Does it set a code? Like, those are the things that I want to know. I want to know specific voltage levels, and ways that I can test the circuit, and what strategy is being used and when by the computer. But we don't always have access to that. If it's not in service information, if it's not in some database, we're kind of on our own to figure out exactly what's going on. Because if we can't figure out how the computer is assessing the circuit, or what it's looking for or not looking for, and when it's looking for it, we're going to have a tough time finding a fix for it and, making an accurate diagnosis. So this is a really good skill set for a diagnostic technician to have, is to be able to dive into maybe not even an unfamiliar circuit, but an unfamiliar vehicle, unfamiliar control module, and make some tests and get to a point where you're saying, okay, here's how the computer's looking at the circuit, and here is what it's looking for, when it's looking for. This is what's wrong based on that information. So I'll share some tips and some things that I, think about and do in these situations to help me through this when I don't always have in front of me the info that I want. So one of the first things I consider when I'm jumping into this, I'm looking at any circuit on the car, really. It doesn't even necessarily need to be connected to the computer, but especially when it is connected to the computer, I'm going to divide the circuits that I'm dealing with into one of two categories. And this is going to help me out a lot in order to assess the circuit and pick what tools that I'm going to use to assess the circuit, but then also kind of get inside the mind of the computer, if you will, on how it might assess the circuit. Why it might set a fault code for a particular circuit is considering, is this circuit doing work, or is it carrying or sending information? Okay, and you can take just about any circuit on the car, again, connected to a computer or not, but we're dealing specifically with computer controlled circuits, and say that this circuit is carrying or sending information, or it's doing work. And what do I mean by work? Like heat, motion, magnetism, something like that, right? And once you divide it into one of those two categories, and there's some examples where a circuit might be doing both, but I'd say it's more common to have it be one or the other, then we can change the tooling and change the assessment of the circuit, right? And just a real quick example of this is, if a circuit is information, let's say like maybe a CAN bus or an input from a throttle position sensor, right? That I would say that's information that is not doing a significant amount of work. An amp clamp on one of those circuits, probably not my first go-to thing that I'm going to use. The amount of current that's going through those circuits, not crazy important to me. Now, could you in some situations use that potentially, maybe like a micro amp clamp or something like that, but that's probably not going to be my first tool that I'm grabbing. I'm going to be looking at the voltage, right? And so that's using things like a voltmeter or a scope or something like that. Now, if the circuit's doing work, let's say a headlight bulb, right? Just real obvious. We're carrying some amperage. The current really matters. And I can definitely look at voltage on that circuit as well. But I am more likely to grab an amp clamp and look at the current, and maybe I'm using a test light which demands that the circuit flow at least some amount of current to light my test light or headlight bulb or something like that. I'm going to treat the circuit differently. And this is just a real basic step, but I apply that mindset when I'm jumping in to assess any of these. Once I've, made that distinction, which should be straightforward, if you've been doing this for a while,
It's going to pick my test methods, but it might also give me an idea of how might the computer be assessing this particular circuit, because it does assess, obviously it's going to assess like an input circuit. It's using that information, but it's also going to be assessing the outputs in a lot of cases too, right? And we get fault codes for an output for the computer for one reason or another. But again, how does it do it? When does it do it? That's going to change. And if we don't have that documentation already, well, we've got to dive in there, start looking at it, start looking to see what is the computer doing. Is it doing some sort of self-test? Is it putting some type of voltage out onto the circuit from the computer to assess the circuit? Or maybe it's grounding the circuit and looking what happens to the voltage. Maybe it just has a range of voltage that particular circuit is supposed to be on. Maybe it's inferring the amperage that is, or the current that is flowing through that circuit, and it's going to do that, through some voltage drop in the internal circuitry, but it's inferring the amount of current that's going through there. Which one of these things is it doing, and when can I figure that out? And then maybe can I manipulate this, right? I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. Once I've decided the purpose of that circuit and the tooling that I'm going to use to monitor or assess it, I might start manipulating the car, the engine, whatever the circuit's connected to, just to see what happens and when, right? I was dealing with a solenoid circuit on a transmission of a 2016 Lincoln MKZ recently, and it was kind of confusing as to when and how the computer was even assessing the circuit. I could pretty regularly get it to fault and set a code, but I really wasn't sure when or how it was doing it. And so I had to connect my scope up and sort of manipulate the car to see what it's doing and when. And really what it was doing is it had a constant power on one side of the solenoid, and then it would quickly pulse the control side to ground when it went into this like circuit check mode. It wasn't even necessarily applying the torque converter clutch solenoid in this state, but it would check the circuit, but you had to get the car there and it had to be in a specific state. And I found out it was either running and you put it into drive, it checks this circuit, or, and I only found this by playing around with the car, is if you go into the actuation tests for the transmission in the PCM of this Lincoln, and you activate any of the transmission solenoids, and oddly enough, it didn't have the torque converter clutch as an option for actuation, but you go in and you enter and you activate any of these transmission solenoids with the scan tool, it will check all of those circuits at that point, and it'll code if one of them is outside of the range that it's looking for. Again, only found that out through messing with it, through monitoring it with a scope. And that's one thing I can say. Whether you're going to assess the final fault of the circuit with a scope can be incredibly helpful just to understand what and when the computer is doing something to that circuit. Now, obviously, we can use it to measure the voltage that's present or the amperage that's present, any of that stuff. But it's a way that you can almost reverse engineer what a control module is doing to a circuit, but then, like I mentioned, also really important when it is doing it, right? I needed a scope in order to see when the computer was pulsing this circuit to ground, and that is when it did its check. That's when it was looking for. Now, I still don't know exactly what's going to satisfy and what's not just from that, but now at least I know the exact condition as to when the computer is checking this circuit, when it does its self-test, if you will. And without a scope, I really don't know how I would have known that. It is not in the service information. They give you an ohm spec for the solenoid, and then they have you do some ohm checks on the wires, and that's really about it. And in that specific situation, honestly, the ohm spec didn't get me through it. The solenoid happened to be within the specification, but it did end up being the solenoid that was the issue. But I had to connect to that and see what was happening with the computer in order to know, okay, it's looking for this now, okay, it's faulting. Now, at that point, what can I do to manipulate the circuit to maybe make the computer happy? And this is the next thing that I'll try to do is there something I can substitute into a circuit to satisfy the computer? Or you could even take this approach, right? Maybe it's an intermittent fault that you're chasing. I hope that that's not the case, because I hate chasing intermittents. But what could I do to a circuit to get it to fault in the same way? That can be useful information, right? If you know exactly how to dissatisfy the computer, it might help you find out what's actually wrong with the car, what's actually wrong with that circuit. If you can get it to set the same code intentionally, well, you know exactly what it doesn't like. But in a lot of cases, what is even more helpful is if it's broken right now, it's setting a fault for a particular circuit. Can I substitute something else in place to satisfy the computer? And this can take a whole lot of different forms depending on what you're dealing with. In this case, on this solenoid, on the Lincoln that I was referring to, I was actually able to put my test light in place of the solenoid on this circuit and satisfy the computer. Now, my test light's not going to work the same as a solenoid inside of a transmission, but electrically speaking, it satisfied the computer. And I knew that the computer was looking at that circuit because I had scoped it, because I had saw when it does its thing. And again, that's only if you're running and you put it into drive, or you actuate any of the transmission solenoids with a scan tool with a key on. So the engine doesn't even have to be running. And that was where I got, so like, okay, I can easily get this thing to code. I can easily get this thing to check the circuit. Well, I put my test light in place of this, and that satisfied the computer. Now, I didn't know if that was going to work, but I knew when it was going to check for it. I knew what it was doing to check the circuit, and I'm going to put something in there of a different resistance. In this case, it was a higher resistance that satisfied the computer. Okay. But again, this can take a lot of different forms. What substitution are you going to use? Now, that might require, a little bit of knowledge about the particular input or the output that it's connected to, that it's assessing, right? And I might ask myself, okay, what's the function of the component that it's connected to? If you can find a specification for resistance or some other electrical quality about that component, obviously that's going to be helpful. Maybe you can use knowledge, from previous vehicles to say, okay, well, this solenoid, should be within this range. Can we mimic something there? If it's an input, a lot of the times what I'll end up doing is using a variable resistor. Or if I know the resistance that should be in there, like an airbag, for instance, the squibs in the airbags are 2 to 3 ohms on most applications. Can I just put a resistor in there, right? The AES Wave Kit is fantastic for that. You pop that in there, and then you see, is the computer happy with this in place? Because I know it should be. I know that's the resistance. I put that in there. I know that that's happy. Now, you could take a different approach to that airbag too, right? You've got 2 circuits going to that airbag, and if you understand what a computer is doing in an airbag circuit, it's going to use some more advanced monitoring of these two different circuits using voltage that's coming from the computer, well, can we get this to set different codes, right? I was just going through this with Andrew, and we were manipulating the circuit, and make sure you disconnect the actual airbag itself from the circuit before you do this, just for safety's purpose. But we had the airbag disconnected from the circuit, and we were manipulating both of the circuits to see, okay, can we get this computer to set a different code if we do this, right? If I short this to ground, does this now have a short to ground code instead of an open? If we put some battery voltage safely, you need to do this the right way, but can we get it to set a short to battery code on this particular circuit, right? It's just a way to see, hey, can we affect this circuit and get the computer to react in the way that we expect? Okay, maybe we can say the circuit's good at that point. Don't forget also that you might have another known good on the vehicle that you're working on. All right. In some cases, that can be an input or an output. But for instance, when I do wheel speed sensors, a lot of the time, and this is for the MR style, digital style wheel speed sensors, these can be fairly sensitive on the vehicle as far as aftermarket parts go, and it'll set circuit codes on these sometimes even before the vehicle moves. And a lot of the times what I'll do is I'll just use another wheel speed sensor on the car. Right, if it's setting a code for the left front, I'll use the right front and see if I can satisfy that computer, right? Because, well, guess what? The other side is not setting code right now, but the one side is. Well, I'll just bring that good sensor, if you will, over, connect it up with some wiring, and then see, does that satisfy the circuit or not? If it does, okay, well, I can say that sensor is probably bad. But if it doesn't, I need to go further and see where else is the fault in that circuit. I had a Mercedes recently that somewhere along the line, a used ABS module had been installed, and they put an all-wheel drive one into a rear-wheel drive setup, and apparently between these two, one wire for the left front wheel speed sensor changes pin location on the module. And I was talking to the shop, well, we can try repinning it and see if that helps. They elected to just get the correct ABS module for it. I tried coding it too, and I wasn't able to change the coding. But anyways, the known goods on the vehicle can really, really be helpful. If you know one is working and the other isn't, okay, we'll swap them around. And the outputs are like this too. Now, you don't always have that case. Sometimes it's just one, right? If it's a fuel injector or a coil or something like that, okay, cool. We got multiple options. Let's connect it up and see, does that change things for us? But if you only have one, well, then you need to be more creative in how am I going to substitute this in? What components can I use? And this takes some time to kind of build an arsenal of different electrical components that you could connect up to a circuit to mimic something else. And, a lot of the times ends up being some type of light bulb that we can use in place of an output, right? I have bulbs of various amperage draw. And depending on what my output is, I'll use a different bulb, whether that be in my test light or maybe an actual headlight bulb or something in between. I can change the current demand on a particular circuit and do my best to mimic a particular output. Now, even with that, sometimes I fall short. I had a trailer brake on a GM truck about 6 months ago or so that I was pretty certain that I had the correct substitution for a trailer brake circuit that would satisfy the control module. Well, turns out I didn't. Turns out it has to be in a specific ohm range. And I can tell you on those GM trucks, if you're going to test the trailer brake, the factory trailer brake circuit, just get the IPA trailer tester. It took me a long time to get to that conclusion, but it works really, really well. And I don't know, it's like 120 20 some bucks or something like that. Well worth it. Just go buy one if you're doing one of those. It makes it so easy. But I went through a lot trying to satisfy that circuit with the traditional method for trailer brake circuits that I've used in the past. And that doesn't work on those. It took me a known good. It actually took me a known good car that wasn't having a fault to find that out. And turns out it was in the trailer, and that does seem to be the case a lot of the time. But those systems are kind of particular about the trailer that they hook up to. And they're particular about the amount of voltage on that monitoring circuit. That one's actually a pretty complex monitoring circuit on there. If you look at it, it uses like a 5-volt pulse on the output circuit to the trailer brakes to determine is a electric trailer brake connected up to that 7-pin connector at the back of the truck. And you can scope that and you can watch it. And I ended up using a variable resistor and dialing it in and figured out exactly what voltage and what resistance was adequate to satisfy it and to not set this code. But then, mimicking that with a load, I really wasn't able to do that until I bought this trailer tester, and this thing works great. And then it's got a long cord, so you can be up at the vehicle and look at the application and all that stuff. So again, that's a learning process that I had to go through. Now I'm set up for those. Not only do I understand the circuit fairly well, but I have something that I can put in place of that to satisfy it. And I understand the strategy a little bit too. And it beat me up, right? But it was scoping, it was looking at the circuit, it was trying different things, using the scan tool. Again, the when of things mattered with that as well. Well, a couple different things that I learned on this. My top-down, for whatever reason, was not great at communicating with that particular module. It's a chassis control module. Data stream was a problem, and for whatever reason, it just had issues. I had to use the Autel on that. Also, the codes won't clear on that particular application on this Chevy truck until you do a key cycle. And that's a big one too, is like, what does it take to reset the computer's monitoring of something? A lot of times it is a key cycle. A lot of times there's going to be a default status that a vehicle goes into, and you've got to cycle that key in order to reset everything. Or maybe clear codes, but maybe a key cycle is what you need so that the computer monitors again. Dodge Caravans, the 6-speed transmission, they're used in other applications too, but the Caravan's the most common one. It would assess the transmission solenoid circuits when you keyed it up, but if it set a fault, it would kill power to that solenoid pack. There's a single power in and multiple control wires. It would kill power to that as soon as it saw a fault. And as long as you had that key on, it was in that fault state. Well, you don't have power to those solenoids, and the computer is no longer monitoring that circuit. It's just gone into a fault state. And so you're not really going to be able to do a whole lot else with it. I mean, you could test the outputs themselves, but as far as using the computer to help you through that, it's done until you do a key cycle. You need to know that. Again, assessing the circuit using a scope or some sort of other, voltage monitoring is what's going to get you there. And that's probably the last thing that I wanted to mention here was remember to let the computer do the work for you here, right? In a lot of cases, we're trying to satisfy or understand what the computer's doing, but do keep that in mind that the computer was designed, hopefully, well, to assess the circuit. And you can use that to your advantage, right? You can save time. And a lot of times you may not even need to get out some sort of monitoring device like a scope or anything. If the computer and the scan tool show you what's going on in that circuit, you can gain a lot of ground just by looking at, okay, what does the computer see on this circuit? If I do this, does it change to something else, right? And the really, really basic version of that is like a coolant temp sensor, right? We're looking at it on the computer. If we unplug it, does it go to -40? If we jump the two pins together at the coolant temp sensor, does it go up to the maximum temperature, 270, or whatever the highest temperature is that it can read, right? We can assess an entire circuit on both sides in a minute or two, and all we needed was a jumper wire at the coolant temp sensor and a scan tool. All right, the scan tool helps, but we're letting the computer do the work. I mentioned the airbag circuits, right? We're putting a resistor in place, and we're letting the computer assess all of the circuit instead of us. Now, again, you can use a scope to help you understand what the computer is doing there. And like in the airbag circuits, it's a bit more complex than just a thermistor circuit that's using 5 volts. And it's interesting to see that stuff. But again, in the interest of efficiency, letting the computer do all that work that it was designed to do can be really helpful. But again, it depends on you understanding what exactly that input or output is, right? Understanding that squib in that airbag is about 2 to 3 ohms, so that I would know to put something about 2 to 3 ohms in place of there. Or understanding, that a thermistor is a component that changes resistance with temperature and what the limits are. I can assess that circuit pretty quickly. Again, letting the computer do the work for you there is a big time saver. So that's kind of what I got on this. And just to get your mind going as you're out there looking at some of these codes and some of these problems with computer related circuits, is to kind of help you get into the mindset of the computer, of maybe something that you don't have a ton of information for, some things you can do and check for, and tools that you can use to help you get there and help you assess what's going on and get to the failure, the fault point in that particular application. So anyways, with that out of the way, I'd like to thank everybody for listening to the show. Always appreciate it and appreciate all the feedback. Keep that up. Otherwise, let's get out there, start fixing the world one car at a time.